Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. This is a weekly session that we have as part of Meetup, and it's just for beginners to get to know Python and also learn some machine learning. I'll be dealing more with the Python side of things. Next week and the week after, Arun will be taking the sessions and he'll be looking at machine learning. Now, the first Tuesday of each month, we have a I'll just turn off this. The first Tuesday of each month, we have an absolute beginners session, and that's for people who've never seen Python before. I'll be following along in the Google chat, and I'll also be following along in the Slack channel Learning to Code. There's instructions in the YouTube on how to join that Learning to Code Slack channel. But if you can't do that, just put some comments into the chat session on YouTube. So for those who are joining us, love to hear from you in the chat. Let me know what experience you've currently got. Whether you've done a bit of Python and can't make sense of it, or whether you've used other programming languages and never used Python before. And that way I can try to customize what we talk about to match what your experience is. Okay, so on the Meetup page and also on the YouTube page, I've put a link to a Colab notebook. This notebook will allows you to run Python without even installing Python on your computer. So it'll have some exercises in there. It'll have some spare spots where you can type in code yourself and run it yourself. So the first thing to do is to go into Colab Notebook. So you just click on the link. And that will, I'll just check where my microphone is. Oh yeah. Okay, so this has taken us into Colab, and if you just have a Google account, then you'll be able to use Colab for free. So the way it works is it's just a bunch of cells, and in each cell we can have text or code. But the first thing you want to do is you want to make a copy of that to your own Google Drive, and so you'll see a button here saying copy to drive. So if you click on that, that'll make a copy of it, and then you can make changes, and you don't and you're able to save any changes that you've made, and you won't affect the main template notebook. Alright, so you can see up here the name of it is now called Copy of Meetup 97. I'm just going to hide that message. And let's start. So you can see there's buttons here. We can add code cells or we can add text cells. And also when you hover between the cells, you can also add another code cell or a text cell wherever you like. So this first cell is a text cell. I've just put that in using Markdown formatting. And it explains what we're going to do today. So we're going to be using interactive Python, which is a particular sort of Python. Everything that you learn, or most of the things you learn in interactive Python will also work in just straight Python. But interactive Python is a lot easier to learn with because you can you get immediate feedback when you're typing things. We'll be looking at some data types, how to store them in variables. We'll do a bit of scripting, which is writing short programs, and looking at the program structure. Here's the links to that Colab, the original Colab notebook. There's the Meetup, and also on GitHub we store copies of all these sessions that we do, and for these ones I store them as a Python file, not as a notebook. So if you're trying to run it with just Python on your computer and you don't have Jupyter notebooks, then this is the file to get. Go to GitHub, this folder here, and find Meetup 97. Okay. Now, as I go through tonight, I'm going to be making some changes to this one and typing things in. So if you can't follow me, I'll give you a link to this. So I'll paste this. So I'll copy that link and I'll put it on the YouTube chat. And I'll also put it into Slack. So you can refresh from this link and you'll get any latest changes that I've made. All right, so we're using Google Colab today. If you want to use Python, you can get Python 3.9.2 from this link here and install that. Some people also use Anaconda. I prefer to use Python myself, but a lot of people in data science, Anaconda comes with a lot of the stuff you need for data science. So if data science is where you are at, then maybe Anaconda will suit you better. I like to use an integrated development environment as well. So PyCharm Community Edition is the one that I prefer. So you can get that from this link. I've also got a Python coding course. You can go to pythonator.com. It's more designed for kids. And you write Python programs to interact with a game. And it's a multiplayer 3D world like Minecraft. And so to do that, you just need the EduTools plugin for PyCharm. So I recommend that as well. Okay, let's get going. To use Google Colab, you can type into any of these cells, and you can see they're just these rectangles. And then you have to execute the cell by typing Shift-Enter, or there's actually a couple of things. So see, I hover here, you can use Control-Enter on Windows, or on Mac you can use Command-Enter. The first thing we're going to learn is the question mark, so that gives you a help menu. And this just works in Jupyter Notebooks. It doesn't work in straight Python, but it is a good way to get started. So that's a text cell. This one here is a code cell. We've written 4 lines of code here. The first 3 lines all start with this hash symbol, and that's because they are comments. And the comments I've put in is just telling you that these are comments and giving you a bit of an idea what to do. Google Colab has conveniently color-coded these with a green so that you can see that they're not being used as they're not actually going to do anything. But here's the question mark. Now if I press Control-Enter or Shift-Enter, it'll run that question mark. Now the very first cell we run in Google Colab is going to be a bit slower than the others. But that's because Google Colab's got to load a whole Python environment for you, and up until now they haven't been sure you're actually going to do it. But here we go. I did a question mark, and it's brought up some help here about interactive Python, so you can read through that. And one of the other things that you can do is where you can do help on particular commands. So question mark word, for example, will give you help on particular things. And I'll let you try that. Okay, I'll just close this help for now by clicking the X. Okay, so the first thing we're going to do is talk about variables. Now variables are memory locations where we store data. So whenever we're writing a program, we want to be able to store our data somewhere, and we put them into variables. So they are memory locations. You can store any types of data in them. You can put numbers or text or complex data structures into them, and you just give them a name. So it's a name that you can remember, that so you can refer to it later. So for example, if I give it a variable the name A, I can just type A equals 3, and it'll take the data 3 and it'll store it into the variable called A. So to run that, I could press the play button, or I can do Control Enter, and that's been run now. So that data, the number 3, has been saved into the variable A. Now if I want to see what's in the variable A, I can print it. So to print it, I use this command here, print, and then I open parentheses, and inside the parentheses I say what it is that I want to print, which is the variable A. and that'll retrieve the data that's in that memory location and return it. See, it says 3, so we can see that the number 3 is what data is being stored in memory location A. So that's straight Python. It works here in IPython as well. Because we're using IPython, there is actually another way of doing it. We just have to type A, the last thing in a cell. If it is returning a value, then IPython will display it for you. So just the last line. So if I press Shift Enter or Control Enter there, I get once again it shows me what's in the variable A. So this is really handy. It's really quick to get values out and see what's going on. So for example, I can type A plus 4, and this will evaluate the expression. So A plus 4 is a mathematical expression. It adds 4 to the value of whatever is in memory location A, which we know is 3, and the answer IPython will display. And there we go, 7 is the answer. So I hope as you're going along, you are pressing on these play buttons and running each cell, and you're getting the same answers. If you're not, then definitely let me know, and we'll see if we can troubleshoot what's going on. Okay, so here's a mathematical expression. I want to take the value in memory location A, add 15 to it, and then divide by 4. And the result of that I'm going to store into memory location B. So I've just made up another variable name, which I've called B. And if I do that, it won't actually show me the result. So I want to see what the result is. So I've done another line, and the last line has just said, show me the result of what's in B, just by putting the B there on the line by itself. And so sure enough, the answer is 4.5. So we'll start talking a bit more. We'll talk a bit now about a more advanced topic, which is what names can we give to our variables, or what names can't we give. And the names we can't use are the Python keywords. So if you want to see what a list of Python keywords are, we can import this standard library, and we can use some functions of that. So I'm just showing you what it looks like. We don't have to understand import in much detail at this stage, but just by saying import keyword, it gives us access to the standard library, and then we can do things like keyword.keywordList will tell us all the Python keywords there, and we're going to print that. And we're going to find out how many there are by using this length function, and we're going to also use the sys library to find out what version of Python we're using. So if I run this, it gives me this is the first print command is the first line, and then the second 2 lines are the second print command. So all of these words in this long list are the Python keywords. So you can't call your variables these names. If you look, there are 35 keywords in Python 3.7.10. There you go. So up until now, we've Google Colab has only been giving us version 3.6 of Python, but today they're giving us version 3.7. So that's a big milestone, even though you can now download 3.9 from python.org. Okay, so there are 35 keywords in Python, so it's not very many, and there you can see all of them, and today we're going to cover about half of them. If you had Python 3.8, that's also got 35 keywords, and I was just saying, so these ones here, async and await, they're new ones that weren't in Python 3.6. I didn't realize they're in Python 3.7 as well, but obviously they are. So let's look at a couple of these keywords right from the start. So none. What's none? So none is a value to give to a variable if you don't want it to have a value. So if I say n equals none, and then I say what's in n, it'll just tell me there's nothing there. So it doesn't even print anything. So if you've put a value in a variable and then you want to clear it out, you can, but still have the variable defined, then you can just put none in there, and there's just no value at all. In other languages, that's called null or nil. Okay. Let's have a look at another keyword, pass. So I'm just picking up some really easy ones here. Pass is a keyword which actually does nothing. So if you put pass in your program, it'll just skip over that step and do nothing. And sometimes you need that, so it's got a use. You probably won't need it much, but when you're in your early days. As you can see, that did nothing. Well, all right. So when you're making up your variable names, you want to you avoid clashing with the keywords. So a good idea is just having long variable names. If you want to do that, the convention in Python is to separate words with underscores, and so you have something like a long variable name. And so let's have a look at that, and we'll see its value 345. Okay, racing along. Data types. We've been looking at some numbers. Like I said, you can also have text, and then also some complex data types. So let's have a look how Python defines them. We've got our variable a. We want to use this function here is called type, and it's a built-in function, so we can use that. And we call the function by using the function name, which is type. Then we open the parentheses, and inside the parentheses we put what we want to find the type of. So it can be a variable or literal data, and it tells us it's an int. So int stands for integer, and it's a whole number, so it's got no fractional part. So there we did a variable. Here we can do a literal value, just the number 456, and that's also an int. Now remember, before we did the type, we did the variable b. That was the result of an equation. If we look at the type of that, it's float. So float are numbers which have floating points, decimal points in them, so they have a fractional part. It could be that the fractional part is 0, but because it's of type float, it will always show the fractional part. If you want to type a number in, if you don't use a decimal point at all, like in 456 there, it will be considered an integer. If you do put a decimal point in, even if after the decimal point is just a 0, it'll be considered a float. So here's an example of a very big number with a 0.0 at the end, and I'll show you how floating point numbers are stored in Python. If I now control enter to see how that's stored, it's 1.23456, etc. Times 10 to the 19th power. So this is called the exponent. The rest of this is called the mantissa, and that's why they're called floating points, because this point in this case is 19 places from the end, because it's by 10 to the 19th. By changing this exponent, you can the decimal point changes its position relative. Well, it's a different position, and so that's why it's called a floating point. So here we go, a very similar number, just with a different exponent, 10 to the minus 14. So that moves the decimal point 14 places to the from the mantissa. You move it 14 places to the left. All right. Now I mentioned before we could store text in our variables. So to put text, we enclose the text with quotes. We can use either single quotes or double quotes, and really there's no difference between them. A string created with any of these will get stored in the same way, but the advantage of using different sorts of quotes is it makes it easier to type the string in. So for example, if you had a string of text which had something inside it that had double quotes in it, then it's quite tricky to use double quotes at the ends to show where the string starts and finishes, because as soon as it gets to another double quote, it'll think that's where the end of the string is, and then it'll have this other stuff after that which it won't know what to do with. So if we've got double quotes inside the string, then the easiest thing is to use single quotes outside the string to show where the start and finish of it is. Similarly, if we've got single quotes inside the string, we use double quotes on the outside, just to make it easier. If you've got single and double quotes in your string, then you can do what's called like a triple single quote or a triple double quote. So where it'll start with a triple single quote, and then the string will continue until it finds another triple single quote. The advantage of the triple versions of these quotes is you can also embed line feeds into the text. So let's have a look at what these strings look like that we've created. We'll use print functions to print these 4 strings, which we've imaginatively called S1, S2, S3, and S4. And we'll look at the type of it. Okay, so when it prints out, there we can see our double quotes printing nicely. The second string, the single quotes are showing nicely. Now the third string, you can see we've got a line feed after embedded, and then it goes, the start of the next line is line feeds. Now when we've typed it with the word line directly underneath the letter capital A, but when it prints out, we've got a big space there, and that's all of these spaces because they're all included in the string as well. So if you want to get around that, you do it like we did in S4, is we did the line feed, and then the next word starts hard up against that left margin, so there's no spaces there. And the last thing we did was display the type of S1, and it's str, so that's Python for string. Alright, so for the advanced users, we've got sometimes you'll want to put a special character in there, and to do that we've got these backslash codes that we can use. So \n is the code for a new line, \r is the code for a carriage return. Sometimes we want to put a single quote inside a string that's delimited by single quotes, and in that case we can use \single quote to show it. Similarly, we can use a double quote by escaping it with a backslash. So the real question is, if backslash does all this stuff, how do we actually show a backslash if we want to? And the way to do that is a double backslash. So see if you can predict what this is going to print like. What have we got? Yeah, new line, carriage return, single quote, double quote. So we're going to print the number 1, then the new line, then the number 2, then the carriage return, the number 3, single quote, number 4, a double quote, number 5, and a backslash. So, and this is the answer we get. So is that what we were expecting? So it printed the number 1, then it did a new line, so it went down to a new line, then it printed the number 2, well, we can't see it there, but then it did a carriage return. So what carriage return does is it takes you back to the beginning of the line without dropping another line, and so the 2 then got wiped over by the 3, the single quote, the double quote, and there's the backslash. Any questions? Okay, more advanced topic on strings. Sometimes you'll see in a string, you'll see a letter in front of the quotes. This letter can be either a U, a B, an R, or an F, or sometimes you can have a combination of them. So a U means it's a Unicode string, and that gives you access to all the Unicode characters. In Python 3 you don't need the U there because by default all strings are Unicode. But if you're using Python 2 and you want to use a Unicode string, then you'll have to put the U there. Similarly, in Python 2 the default string type is bytes. So each character in a string is exactly 1 byte long, and that gives you access to all the ASCII characters and a little bit of extra, but it doesn't give you access to anything more than a single byte Unicode character. So by putting a B there, in Python 3 you can make your string a byte string. By default it's that in Python 2. So if you're writing code that you want to work in both Python 2 and Python 3, then always stick a U or a B in front of any of your strings so that it will work in both versions of Python. My recommendation is that's too hard. Just stick with Python 3. Python 2 is on its way out. It's hardly used anymore anywhere. Okay. Now sometimes you'll see an R in front of the string, and a R means it's a raw string, which means don't use the backslash for any of these special characters. A backslash is just a backslash. So you'll see if we print out these strings, let's have a look at what they look like. So backslash slash is just a backslash, and so you're typing all these things and none of them get escaped. It's just a backslash. And that's pretty handy when you're doing regular expressions and other things that have got lots of backslashes in them, because it gets really confusing when you're having to escape backslashes with double backslashes. And finally, the format string, and this was introduced in Python 3.6. And a format string makes it easy to display values and expressions. So, for example, if we want to see what's in A, we put an F out the front, and then inside our string we can put the variable A inside these curly braces, and it will print out the value rather than the A. So we can see 3, 4.5 for B, and 7.5 for A plus B. So it's actually even evaluated the expression and then just displayed the result. So as I'm going along, let me know if you're finding, if I'm talking too quickly or going over stuff through quickly, or it's too easy. And definitely ask questions if you've got any questions about any of this. All right. Now, so we've done a few simple data types. Let's look at some operators. So operators are these things like a plus, a minus, times, divide. And so they're good for doing expressions. So let's have a look at the integer operators. We can, and I've put them all in format strings, so let me know if that's confusing. But I think it just displays the results quite nicely when I print them out. So you can see 27, which is what's in A, plus. So I've just written the word, the operator plus there, and then what's in B, which is 5, returns, and then I've put the whole expression in another set of curly braces, and it gives me 32. So we can see the plus sign is used for addition, the minus sign or dash is used for subtraction, the asterisk is used for multiplication. So double slash, that's used for integer division or floor division. So what it does, it says 27 divided by 5 gives you 5. It gives you 5 remainder 2, but we just want the interdivision part of that, the quotient. So it's just giving us 5. If we want to find the remainder, we can use this operator, which is %. And so 27% 5 returns 2, which is the remainder or modulo. And the final operator I'm dealing with here is the double asterisk, and that's the power. And so 27 to the power of 5 gives this quite large number. Okay, so for all of these operations, it required both values in the expression to be integers. Now, if one of those values is a floating point number, then the result will be a floating point number. And so you can see here 27.0 plus 5 returns 32.0. So this 32 up here is an integer, this 32.0 is a floating point number. And that's how you can tell by when it gets displayed how it's stored, whether it's an integer or a floating point number. So all these are the same. When it comes to divided by, we've now got two options. We can use the whole number division and to get 5.0 for 27 divided by 5, or we can use floating point division, which is just a single slash, and that gives us 5.4 as 27 divided by 5. Modulo still works the same, and power works the same. And if you want to get really advanced, you can use these, have a look at these bitwise operators. There's like the pipe symbol, the ampersand, circumflex, double less than sign, double right than sign. So these are bitwise OR and exclusive OR, shift left, shift right. And if you study through this, you can see that I've used some really fancy formatting capabilities of these Python format strings, which start with an F. So I'm starting with an F here. I put values in here, but you see sometimes I put these colons. So anything after a colon in a format string is how you want it to be displayed. So I want A to be displayed as right justified. I want A or 3 to be displayed taking up 2 characters of width and right justified. So 10 or 3 returns 11, and that's right justified. And that way, see, I've got them all lined up nicely here. How did it come up with those numbers? Well, I've used colon 4b in this case to display A a different way, which means I want to display it as a binary number, B for binary, and I want it to be 4 characters wide. So here it's displayed 1010. And similarly, the number 3, I want that to be displayed 4 characters wide in binary, and I want it to be aligned, right aligned, but also padded with zeros. And there you can see that 0011. And if you look, so that's all the bits that make up these decimal numbers, and the bitwise operator OR says if that bit or that bit, then we get a 1. If both are 0, then we get a 0. So that's how we get 1011 as our answer in binary, and that converts back to the number 11 in decimal. I won't spend too much time on that unless you've got questions. Okay, so we've done operators on integers, we've done operators on floating point numbers, we've done bitwise operators. Now we'll look at string operators. So you can use the plus sign or the asterisk for string operators. And here's an example. If I say the string well times 3 plus 3 holes in the ground, the string that I get is well, 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 3 holes in the ground. And so it's taken that string 3 times and then added it onto this string and returned one long string. Okay. If you're using adjacent strings like this, you don't even need the plus sign. You can just leave a gap, a space in there, and it will concatenate them all into one long string, as you can see here, 1, 2, 3, 4. Okay, so let's have a look at some interesting side effects of the different data types that Python has. The way it handles integers, it will always preserve all the digits of an integer. So as the integer gets bigger, it can start off using 32 bits of data. If that's not enough, it'll go up to 64 bits of data. If that's not enough, it'll just keep growing the integer so that you can still use the integer to all its significant digits. which means that sometimes your integer mathematics can have more significant digits than your floating point numbers, which is different to other languages. Other languages, your integers will often have an upper limit. So the upper limit on a 32-bit integer is often, it goes from -2 billion to about +2 billion. But in this case, if we do 25 divided by 7 in floating point, it just gives us that number of digits in the response, which is about 17. But if we used integers and integer division, we get many more digits. And so this is useful if you're, for example, running a calculation for pi to hundreds or thousands of decimal places. You can use Python for it and just use integers in your calculations, and you can get very, very, very long numbers. The problem with that is if you've got a lot of those very big integers, they will use up a lot of memory, but that's memory is quite cheap these days, so that's not a huge issue. Floating point numbers, they always use the same amount of memory, each floating point number, but the range of numbers that they can handle is quite large. But the problem is floats can't store decimal numbers exactly. They can store integers exactly, so anything 0.0 will be stored exactly, but anything 0.1 or 0.2 won't be stored exactly. So sometimes you'll get strange results. So if we look at this, if we add 1.1 to 2.2, we get 3.30000, so on up to 3. So that's okay for science because the magnitude of the number is about right, but for accounting that's no good. So if you're using accounting, then you're better off using integer for cents rather than floating point number of dollars, or if you can even use a special class called decimal in accounting, which will allow you to have decimal places, but they will preserved, and you'll always get an exact number here. All right, so challenge 2. The first challenge was installing software, if we've done that, but this is we're now going to do a challenge, and I left some spots here for you to do them. So have a go at these. If you like, you can pause the video and have a go yourself, and then I'm about to go straight into the answers. So then play the video, and you'll see what answers I've typed in, and I've got the answers down further anyway if you just want to watch along. So the easiest way to do this is 1, 2, 3 plus 4, 5, 6 and shift enter, and it calculates the result as 579. Okay, so that's pretty easy. Next one, find the integer quotient and remainder when dividing 66666 by 235. So we've got integer quotient is / divide by 235, and to get the remainder it's % 235. Okay, so if I run that, I only get one result, and that's because interactive Python, IPython, will only display the result of the last line. So I've got two solutions here. I can either put a print, each one in a print command, and that'll print each of the answers, or I can put them both on the same line and just put a comma between them. And then I'll get the two answers. It'll actually put parentheses around them, but we don't have to worry about that for now. But there's the answer. The integer quotient is 2,836, and the remainder is 206. All right, 2 to the power 10. $1,024. That's correct. And now we'll look at the floating point. Division, and it's 2836.8765, and so on. All right, store in a variable name. In a variable, the name of your favorite programming language is a string. So let's go s equals Python. Okay. Construct a new string. So let's call it new string, which if I type properly, equals, and it's going to be programming in with a space plus the variable. Okay. Here's fun. And then if I want to display that, we'll see what we get. And there's the string. Programming in Python is fun. Okay, so that's what I've done for my solutions. And here's some solutions that have been provided. And this one's been done using format strings. So they're a little bit more complicated to read, but they display a lot more nicely. And yeah, we use pretty much the same way of doing it. So let's 1, 2, 3 plus 4, 5, 6 returns 579. 6 sixes divided by 235 gives integer quotient 2836 and modulo 206. 2 to the power 10 is 1024. Yep, so we got all the same answers. Very good. Okay, so let's look at another data type. We've done integers, we've done floating points, we've done strings, and we've also done none, which is another data type. And now we're going to look at Booleans. So in these are true or false. And you notice when you type true or false, these are actually keywords in Python. You'll remember from our list of keywords. It's important to get it case sensitive, so you make sure you put a capital T and a capital F on them, and all the other letters in lowercase. So the type of true is a bool, type of false is a bool. So bool is the Python way of saying Boolean. You'll often get a Boolean when you are testing something. If you're seeing if two values are equal, or if or one's less than another. And so all of these conditional operators, so we've done the mathematical operators before, like the plus, minus, divide, times, power. Now these are conditional operators. So we've got double equals, exclamation mark equals, less than, greater than, less than or equals, greater than or equals. And there's even some which are words. These are actually all keywords: in, or, and, not, and is. So we're racing through the keywords. There's only 35, remember. So we're going to get you're going to learn half the entire Python language by the end of tonight. Okay, so let's have a look at double equals. So remember, single equals is assignment, double equals is the equality tester. So we can test, does 3 equal 5 minus 2? And the answer there is true. So that is true. Is 45 is greater than 23? That is also true. Minus 10 is less than minus 20. Okay, so minus 20 is actually less than minus 10. So that should give us false, and it does. All right, C1 equals Python. So remember, in our answer up there, we stored in a string C1 the word Python. Now let's see if it's still there. It is. C1 equals Python. Okay, challenge 3. Predict the outcome of the following Boolean expressions. So I've put all these Boolean expressions into these format strings and printed them out. So we can see what the expression is and we can see what the result is. So the idea is to go through each of these and work out what the result is and if that's what we were expecting. So I might just run that and we'll go through them one at a time. Okay, so double equals, C1 double equals Python, so we want it to be exactly the same, but that returns false, and the reason for that is because C1 is Python with a capital P and we were comparing it to Python with a lowercase p. Okay, so we could use exclamation mark equals, and the exclamation mark is supposed to look a bit like the a cross through an equals sign, like the not equals sign, and so that gives us the conditional operator not equals. So C1 does not equal Python. That is true. And that's why, once again, it's because C1's got a capital P in Python. All right. Now let's have, we got 1,518 divided by 6, which if we calculate that comes to 253. So that is actually a floating point number. This is an integer on the left, but we can still use greater than or equal on that. And so is 253 an integer greater than or equal to 253 a floating point number, and the result is true. Similarly, is 253 less than or equal to 253.0, and that is also true. All right, so let's have a look at some of the irrational numbers. We've got these out of the math library. So we've got E, which is the base for exponents. We've got pi, which is the ratio of a diameter to a circumference of a circle. And also in the library we've got tau, which is the ratio of a radius to a circumference of a circle. So if we do math.e is less than math.pi, that is true. So that gave us true. Now here's an interesting one. You can't do this in a lot of languages, is have a couple of conditional operators in the one expression. And so we say is E less than 2 times pi, which is true, but it also has to be less than tau, which is false. So because part of it is false, then the whole thing returns false. And so we've got an example there of false. All right, so what happens when we compare strings or characters? We compare lowercase a to lowercase c, and that returns true. So what it's really doing there is it's comparing the Unicode value of the a with the Unicode value of the c. And now, fortunately for us, for the lowercase characters, that is also alphabetical order, so we can see in alphabetical order whether a is less than c. It gets a bit more complicated when we've got upper and lowercase characters, because a less than uppercase c returns false, and that's because all the uppercase characters appear before the lowercase characters in Unicode and in ASCII. So yeah, the word upper is less than lower, catch is greater than carriage, and so that returns false. All right, now we can try using greater than or equals on a list. So we haven't really dealt with lists yet, but a list is a several values all combined and put in square brackets. And so we can compare this list of 5, 1, 2 with 6, 0, 2, and that returns false for greater than or equal, and that's because it starts comparing from left to right. So very much like the strings do. We did so catch is less than carriage. It compared C to C. They were equal. A to A is equal. T to R. T was greater than R. So it goes, oh yep, that's catch is greater than carriage, and therefore that returned false. And similarly, this one returns false because 5 is less than 6. Okay. Now remember I said in was also one of our conditional operators. We can look to see if the letters AT are in catch, and they are, so that returns true. You can have A and C, they're in catch, but they're not in the right order. So AC in catch, that returns false. And they are there. There's an A there and a C there, but there's a T in between, so it has to be continuous. Similarly, TA, they're in the wrong order, so that returns false. Now, if we try looking for a list, this is where lists differ a bit from strings. Is 2, 6 in 5126, and that's not correct because only one element of a list can be checked within at a time. But we have used not in this expression. And this is an interesting way of using not. Most other languages, your not would have to be right out the front, but here we can put not just next to the in. Say is 26 not in 5126, and because that's 26 in 5126 would be false, then not in will return true as it does. Another keyword is or. True or false, that returns true. So if either of them are true, then the answer is true. Similarly for and, you need both of them to be true to return true, otherwise you'll return false. It gets more tricky when you've got true or false and false. And actually has precedence over or. So when it looks at that, it evaluates the and first, and then it evaluates the or. And so the result of this will be true. I can never remember whether and or has precedence, so I would always use parentheses so I know for sure which one I'm testing first. But if you don't put the parentheses in, that is the order it will be tested. And you can see the same thing, false and false or true returns true because the and is done first, then the or is second. So false and false is false, then false or true is true. Okay, and finally we're going to use the is keyword. We've used it up here. So we said C2 equals C1, and then we said C1 is C2. We've checked that, and the answer is true because they refer to the same location in memory. So when you're deciding whether to use double equals or is, in your early days, you pretty much always you're going to be using double equals. Is going to be unreliable. It'll work for you sometimes, and then other times it'll give you examples you're not expecting because you're in the early days you're not going to be fully aware of where stuff's being stored and when stuff moves in memory locations. The only time I would use is if you're comparing something to none. So if you wanted to see is C1 is none, then you'd use is. You don't use double equals. All right, we've had a little bit of a look at list, but now we can look at it in a bit more detail. So you define a list with square brackets. You can put a comma separated list of any data types in the square brackets. So we've got a string, an integer, a floating point number, and then a few more strings. So we can print it out, and that's what it looks like when we print out a list. Now, list is 0 indexed, so the first item there is index 0, and so if we want to look at, if we want to refer to just the first item, we do list 0, and you'll see that'll return 6. If we want to look at the 5, there we do list 1. And if we look at list 6, that'll show us the last value, which is 0. You can also count an index back from an end. So this is a thing that Python can do that you don't see in many other languages, and it's really useful. If you want to look at the last element, you just say list minus 1. If you're doing this in another language, you'd have to calculate the length of the list and then subtract 1 from that and the index just to find the last element. So list minus 1 returns 0, and you go list minus 2 will return the 1, which is the second last item in the list. We can use this len function. So len's another built-in function to find the length of that list, which is there's 7 elements in that list. So these built-in functions, they're a little bit different to keywords. Like they're available to us straight away. We don't need to import them, but we can overwrite them. If you accidentally call a variable name len, then you will have a variable with that name, but you will no longer be able to call this function because you've redefined what len points to. So len will become a variable name. So it's something you can't do with keywords. Keywords, you just cannot have variable names with those keyword names. But the built-in functions, you can override them with your own. So it's just something to be aware of. I definitely recommend don't do it. So try to make sure you're using variable names that don't override built-in functions. If you're using an IDE like PyCharm, it will warn you if you ever do that. So that's one of the advantages of using those IDEs. All right, slicing through a list. So if you put a colon in there, we can put a value before and after the colon, and that'll return a slice of the values in the list. So list 2:5 will return these three values, 4, 3, 2. So the way I like to think of how the indexes work and how the slices work is that the index refers to the positions between the elements. So index 0 is before the 6, index 1 is before the 5, and 2 is between the 5 and the 4, 3 between those two. So if I want to know what the slice from 2 to 5 is, I just look at what's between them, and that's 4, 3, 2. And that's what gets returned there. So the advantage of this way of doing things is I know how many there are going to be. 5 minus 2, there's going to be 3 elements, and there are 3 elements. So some people think of this as starting from and going up to but not including this value. So yeah, it doesn't include the 1, but it starts from 2. So you just work out a way that works for you for how you visualize these things to make it clear for you. You can even use negative indexes, and they work the same way. So we could have done a slice from -5 to -2. In this case, they happen to be exactly the same numbers. But all right, when you are putting in the first number, it'll default to 0, so you don't need to put the 0 in there. So you could say list :4, and that will give you, I should display the result, give you those 4 values. So it starts at the first one and goes up to, but not including the one with index 4. Slice from index 3 up to the end. So you can't actually specify an index for the last value, because any value you put in there will go up to but not including. So by leaving it as a colon and no value, then it will take you to the end, 3, 2, 1, 0. If you put 2 colons in your slice, you can put a third number in there that is actually your step value. So you got your start value, your stop value, and your step value. In this case, we want to step up in 2s. So 5, 3, 1. And the step value can even be negative. So in this case, we can go from the last value to the first value going backwards. So it's a quick way of reversing your list around. So there we get 0, 1, 2, 3, 4. Now we've looked at all these slices and things, but if you look back at your list, nothing we've done has actually changed anything in the list. It's just we wanted to use these slices. So our list is still as it was originally. But there are some things we can do. We can actually assign values into the list. So we can say we want the list with index 2, the value to be the letters FOUR. So remember, before it's 65 the number 4, now it's 65 the word 4. Similarly, we can make the last value the word blast off rather than 0. So there we've changed the values in the list by using this index notation. We can even delete an element right from the middle of the list. So we can delete, and this is a keyword, DEL. We can delete list 3 and see what it looks like there. And there we go, the number. So that 3 there was the index, not the string. And it's now out of the list. So that's dealing with lists. A lot of things that we can do with lists, you can actually do with strings, because strings are considered like an iterable collection of characters. So we can do slicing. And there we get D, E, F, G. All right, so challenge 4 is what's something that you can do with a list that you can't do with a string. So I might just go use the solution that they've got here, which I wrote before. So S equals, and we'll just do it's these characters here, 6543210, and see what we can do with it. We can print it out. We can look at the index 0, index 1. We can look at last. All right, so let's run this and see what we get. And that was running 56, and there's 57. So yes, we can find these ones are all working. We can find the length of the string using the len function. We can slice it, slice without beginning, slice without ending. We can step up, we can step backwards. That's all working. Right, so these last three, I didn't actually do them, I've just written a message in there. So let's test it and see what happens when I do it. So if I try to assign to index 2 in the string the value f, and I get this type error, string object does not support item assignment, which I've just written in there. Okay, similarly, even with negative index, that will give us the same problem. And if I tried to delete a character out of a string, that will also throw an error. Yep, so that's correct, as was predicted here in the solution. So that means that you can't change a string in place. You can create a new string that is, for example, with one of the characters missing or with one of the characters different, and then you can assign that new string to the same variable name, but it will be you can't change it in place. So it will now occupy a new area of memory. And I'll tell you now, that's what they call it. It's because string is an immutable data type. You can't change it in place. Okay. All right, interesting fact, you can convert a string to a list just by using the list function. So we've created our list S, our string S before, which is a 6543210, which Google Colab is conveniently showing there when I just hover over it. And if I put that into a list and then have a look at what the list is, it splits it all up into one character per element in the list. To convert something back to a string, you can use the string function, but in this case it doesn't reverse properly. When I convert that to a string, you can see now I've got quotation marks around the outside, and then this list in the characters, it's got square brackets and that in this string. So that's not the way to convert back from a list to a string. If you really want to do that, you can use this join function. So for those advanced amongst you, you take the empty string, which is double quote, so it's got 0 length, and use that to join every element of our list and result it in a string. And because it's a 0 length string, that will put all the characters hard up against each other. And there you see, we've got our original string again. Right, so we looked at variables, we looked at some data types, we looked at operators. Now we'll do a bit more programming. Now we've been writing short little programs. You see, we've got 3 lines of code here, 2 lines of code here. So that each one of those cells is a little program. And the advantage of interactive Python is that it's actually storing the values of variables as we go from one cell to the next, so that we could put all these cells together to make one long program. But sometimes we want to do a bit more than just sequentially going through line by line of code. So to do branching, we can use the if command, and it's a keyword, so another keyword. We can so if, and we have a condition that when it's true we do one thing, and otherwise we do something else. So let's we'll import this library, standard library random, and we'll get random to produce a number between 1 and 6, and that number we'll want to see if it's an even number or an odd number. So we've got an if statement here. We put in our condition, so we do modulo 2, so that modulo, remember, gives you the remainder. So we've got an integer, we divide by 2, the remainder is going to be either 0 or 1. If it's an even number and we divide by 2, the remainder is going to be 0. If it's an odd number, we divide by 2, the remainder is going to be 1. So we can check if it's 0. If it's 0, we know we've rolled an even number, and otherwise we've rolled an odd number. And so for otherwise we use the word else. So these are keywords. So you can see all the keywords are coming up in purple in Google Colab, and that just makes it a bit easier for us to see which ones are the keywords. Now to work out which lines of code happen when the if is true and which lines of code happen with the else, Python uses a thing which is quite different to other programming languages, is that it uses indentation to work out where the code blocks are. So after the if statement and the conditional operator, we put a colon. The colon just says on the next line we're going to be indenting with a code block, and there's our code block, and we've got this print statement. Then we remove the indentation by putting the else there, and that's how Python knows that that code block is finished. So then the next code block starts, and we have the code block here for what happens to do if it's else. And then after that you can remove the indentation again, and you'll continue on for code that will happen regardless of whether it's even or odd. Okay, so I've got a question here. Do else and if work the same as in JavaScript? Okay, so I've got to remember JavaScript, but I'm pretty sure it's going to be the same. So in JavaScript you would put brackets, parentheses around your conditional statement. So I'll just write this in how I think JavaScript will work. So if we were doing the same thing, we'd say if, and then die roll I don't know if JavaScript's got the modulo. I'll put it in case it does. Equals 0, and then you'd open up your curly braces and you'd print even, and here you'd print odd. So that's pretty much what JavaScript will look like, and this is how you'd write the same thing in Python. So it's a little bit more compact because we don't have we haven't got 5 lines, we've just got 4 lines for the if and else. Okay, let's try running it. You rolled 2, which is an even number. Yep. And if we can run it again, we rolled 1, which is an odd number. So it's getting the odds and evens right. Okay, so now we'll look at elif. So there's another keyword elif, which is basically else if do something else, and then an else right at the end. So similarly in JavaScript, you could put else if another condition, so I don't think JavaScript's got an else if, but you can just put in JavaScript, you can just do else and if. I'm supposed to have semicolons here as well, I think. Alright, so let's try running this. Rolled 4 and a 3. Your first roll is greater than the second roll. First roll greater than second roll. Both are equal. Both are equal. First roll is less than the second roll. So we've tested each of the cases and they're all coming up correct. Alright. So when sometimes we want to loop over the same bit of code many times, and this is where we can use Python loops. So Python's got 2 sorts of loops. You've got the for loop and the while loop. And they're a little bit different to other languages. So for example, in this one, you put something that can be iterated over. You use the keyword in, which is a bit different. It's the same keyword as we used before. And before we used it as an operator for conditional operators. Now we're using it as part of the for loop. So say for number, that's a variable in our list or something else that we can iterate over, print the value of the number. And so it's printed on each value, each line, 3, 2, 1. So it's gone through the loop 3 times, and each time a different value has gone into that variable and printed it out. And then it's been printed out. Okay, a while loop is like an if statement, except it repeats the code block that's following the while many times. So we can see while, so here we set a counter to 0. While the counter is less than 10, then we keep running. And somewhere in this code block, you'll want to make sure there's something that's going to change the value of counter. Otherwise, you'll have an infinite loop. And here we've got counter equals counter plus 1. And so that takes the value of counter, adds 1 to it, and then uses the equals to assign it into the variable counter. Inside this while loop, we've put the same if, else commands we did before, which have and so we're basically going to run them 10 times. So here, the first roll, we roll a 1 and a 5, and the first roll is less than the second roll. Next time through, so here's counter going up all the way up to 9, and then when it gets to 10, then it's no longer, counter less than 10 is no longer true, so it stops looping and jumps out of the loop. And you can see here, this code block in here is double indented, so you can just keep indenting as you've got code blocks inside code blocks inside code blocks. The indentation, if you've just fired up Google Colab for the first time, you'll probably find you're getting a 2-character indentation if you typed this code in and press the tab. I've configured that in settings, I think. Settings to say I want to use a 4-character tabs, which is what's consistent with indentation. In fact, it's I did this as a different user. But as this user, I make sure that indentation width is 4. So when I press tab, it will go 4 spaces each time, and that's the convention for Python. All right, challenge 5. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay, so I've got a solution here, but I'll do a different solution just so you can see the sorts of thought processes that go through trying to solve this problem. So I'll do a for loop. I'll try it with a for loop. So I want n to be my variable. It's going to go through all the numbers in my list numbers, and I'm going to print n. Okay, so if I run that, and that didn't work because I didn't actually execute this this cell here. So you can see there's no number in there inside those square brackets, and that means it hasn't been executed, but this one has been, because I've got the 73 there. I can't point with the mouse because as soon as I do that, it hovers it. So I want to run this one, so I'll click play on that, and then I'll click play on this one. So that's 74, this one's 75 in our run sequence, and you can see I've now got all the numbers printing out. Right, so I want every number from 0 to 20 as digits. Oh, as digits, so we need digits as well. So let's say digit equals 0 for the first time through. And then we're going to increment digit by 1. So I can use the plus equals notation, and that's the same as digit equals digit plus 1. So there we go, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So that's looking good. And now I want to know whether it's even or odd. So I can I'm going to create a list here called even odd, and it's going to have two values. The first one is going to be even, the second one's going to be odd. And I'm going to display in my print statement n%2. So each time I not n, I want digit. Each time digit gets incremented, then that'll go, digit %2 will go be either a 0 or 1, and then I'll use that as the index to look up this string, this list of strings, to see whether I have to display even or odd. So there we go. 0 is even, 1 is odd, 2 is even, 3 is odd, 4 is even. So that's one solution. Here's another solution, is using the just traditional if-else statement I did before. If I%2 equals 0, then use it's even, otherwise it's odd, and printing it that way. And I've used a while statement because I needed a counter anyway. And then I refer to the element in numbers by its index. And I get the same answer. All right. I said before, I was talking about using importing decimal standard library to solve the floating point problems. If you wanted to do that, this is how you do it. So you import decimal, decimal.decimal, and you put the values in as strings. And the reason you do that is if you put them in as floating point numbers, then you've already lost your precision. It converts it to a binary number from a decimal number before it gets passed to the decimal, and so it can't work it out. So there's the way they've worked around that problem is to put it in as a string, and so the decimal class will analyze that to work out how many decimal places you're actually wanting to use and making sure that they're stored exactly. So to do that, decimal.decimal 1.1 plus decimal.decimal 2.2 gives me a new value, which is decimal 3.3. So this is a different data type. It's of type decimal.decimal, and it's got the value 3.3. We used import this way. You can also use import as from decimal, import decimal. And that means anything else in this decimal library you're not importing. You're only importing the one thing, which is this class called decimal. But because you've imported it explicitly, you don't have to put the decimal name of the library before you use it each time. You can just refer to it by its name here. So now we can say decimal 1.1 plus decimal 2.2 gives us decimal 3.3. And then if you want to save on typing, you can use an alias. So from decimal, import decimal as D. So we're importing decimal, but we're renaming it to D, and therefore we can start using code like this. And sorry, it still returns with the full name, but when you're typing it in, it's a lot less typing. Okay, these aliases can be used on the entire library, and you'll find if you're doing data science, most people will import the pandas data science library as PD and the NumPy data science library as NP. So there's just two ways of importing. Okay, so these are all the keywords we've covered tonight. See if you can remember what each one of them does, or look back through the code and see. I've put them all into a list and calculated the length of this list. So let's see how many we've covered. We've covered 18, so there were 35 total, and I've covered 18. So we've done more than half of the entire Python language tonight. So you've done very well. I've only had one question in the whole one, and it was a so obviously everyone else has followed extremely well. Feel free to keep asking questions. I'm going to finish the video now. Next week in Meetup will be run by Arun, and he'll be looking at machine learning. So and he'll probably do it also in Google Colab notebooks. So you don't need to have Python installed on your computer. When I stop this video, the YouTube chat will probably stop working, but you can still keep asking questions in Slack Learning to Code channel. Thank you for your time, and look forward to being with you again.